Right, welcome to the next session. This session will deal about cubes and dice. And when you look at the weightage of this particular topic, as usual, so here the weightage for this cubes and dice topic last year was 3, right? And 2 and 2 in the previous years. And if you observe over the last 6 years, minimum when there were 50 questions, minimum you had 1 to 2 questions, and when it has become 100, you are seeing definitely 2 and in some cases even 3. And this is quite an easy topic, but you have a lot of things to discuss. So mainly you have 4 types here, 4 concepts here basically. The first one being counting of cubes, and one particular technique for counting of cubes is always count in columns, not in rows, but count in columns. Right, column, this is column, right? This is row, this is column. Now the second one is finding opposite faces from a net of a cube, or finding opposite faces of a cube from a net. And the third one, once again, is finding opposite faces of a dice from given positions. From given positions. And the final one, fourth one, being painted cube model. Previously, they have never asked questions on painted cube model, but last year they asked one question from painted cube model as well. So these are the concepts that we will be looking at. And as the questions are also from these topics, so we will directly go to the PYQs and look at these concepts during the PYQs, right? So moving on to the PYQs now. This is from 2015. You have 2 questions over here, and they have given you 4 positions as well. So if you observe over here, the positions are, so this is the third model which I previously discussed with you, finding opposite faces from the positions of a dice. So the positions are 6, 3, 1, 5, 2, 4, 3, 5, 1, and 2, 3, 6. These are the given positions. Now they are asking you to find the number that is opposite to 4 and opposite to 1. So whenever you come across these type of questions, so what I would suggest you to do is choose 2 positions such that they have only one common face. They have only one common face. But if you observe over here, this particular position and this particular position have only one face common, which is 2. So I don't need the other ones, so I'm taking them off. Now this is the first step. You have chosen the common face. Now in the second step, what happens is you will choose your orientation, whether you are going to go clockwise or anti-clockwise from the common face. Right? Now here what you are going to do is, I am taking clockwise and I am going to rotate this cube. So my options would be, my path would be 2, 5, 4, and here my path would be 2, 6, and 3. Quite naturally, 2 cannot be opposite to itself. So my path I would take as, I would change 1, 2 into the missing value, that is nothing but 1. Now, if you observe here, 4 is opposite to 3. This is my answer. And 1, it is opposite to 2. This would be my answer. Right? So only 2 steps. Find common face, choose orientation, and third path, write the paths. Third part is right path, and we will find the answers quite simply. Right? Moving on. These are the 2 questions from 2015. And moving on to 2016 now. In 2016, once again, you have the same type of question. So here, I'm going to choose 2 paths which have, 2 positions which have same common face, or one common face basically. So if you observe, these 2 positions have 4 in common. So I'm rotating. So 4, 5, 1 and 4, 6, 2. The question is which number is opposite to 6. So over here, the number opposite to 6 is 5. Right? Moving on to the next one. 2017. Once again, you see the same type of question getting repeated here again. So here once again you have 4 positions over here, and they are asking you to find the number opposite to 4. Now what I will do over here is, once again, I will choose 2 positions having one common face, and I will choose the orientation. So my orientation would be 2, 5, 4 and 2, 6, 3, which is once again here changing to 1. Right? So the number opposite to 4 is 3. Is this the same question which I did? I am not sure. If it is, then the questions are repeating in this particular topic. Right? Then moving on, there is only one question in this particular PYQ. Moving on to the next one, 2018. I have 2 questions over here. Now, instead of numbers, what I have is, I have only 2 faces, and they are asking me to find the, I have only 2 positions, and they are asking me to find the opposite face containing 5. So what I will do, I will write this in terms of numbers for my convenience. So this is 2, 5, 1, and this is 4, 2, 1. So now if you observe, 2 positions are common. So the other ones would be opposite to each other. So the number opposite to 5 would be 4. Right? And coming back to the 95th question. So my common value over here, it is 3. So 3, 1, 2. And once again, I'm rotating. It is 3, 5, 6. So same number has been repeated. So I will take off one value. So it will become the missing value 4. So my answer would be 4 is opposite to 3. Here they have given an option of 2 or 3, but no, it is 3. Right? Next. So once again, you are finding the same type of questions. Right? So next. This is from last before year. Right? Now observe. Now, this is the second case which I told you, where they are giving you the net of a cube. So whenever they give you a net, remember that alternate boxes in a linear arrangement, they form opposite faces of a cube. They form opposite faces of a cube. Right? So 1 and 3, they are the alternate faces. 4 and 6, they are the alternate faces, opposite faces. And 2 and 5, they are the opposite faces. Now the question is, which is opposite to 4 and 5? So opposite to 4 is 6, opposite to 5 is 2. So my answer would be 6 and 2. If you take 2 and 6, it will be wrong. You should take 6 comma. You have to follow the order over there respectively. See, you have to follow the order. Next, moving on to the next question. Same model, the same model that you know already. So now they are asking me to find the number opposite to 3. So what I will do, I will choose these two faces because they have only 3 as common, and I will choose the orientation, of course. So that would give me 3, 5, 1 and 3, 2, 4. So now removing the common value and including the hiding face, so that is 6. So the number opposite to 3 would be 6, right? Next, moving on to the last year paper, right? Now, last year the questions have changed a little. In fact, very, very much. Now, as I told, this is the first model of questioning. You are supposed to count in columns. So you will be counting in columns. So if you observe in this column, you have 1, 1, 1 cube respectively. Here 2, 2, here 3. So total number of cubes would be 3 plus 2 plus 2 plus 1 plus 1 plus 1. So 5, 7, 10. So number of cubes are 10. Very easy. After counting columns, if you count in columns, it becomes easier, right? Next, moving to the next question. If you observe here, this is once again the net of a cube. So the net is given like this. This is 1, 2, 3, 4, 5, and 6. So I'll safely draw it to avoid confusion. So this is 1, 2, 3, 4, 5, and 6. Right. They are asking you to find the number of dots opposite to the position 3. Now, if you observe here, as I told, the alternate boxes in linear arrangement. So 3 will be opposite to 5. Right. And then moving on. There is a question over here that is asking you to find the opposite faces. Second, it is not on opposite faces, it is actually on painted cube model. Let's show you the question. Right, this is the question. A cube is colored green on all 6 faces. The side of the cube is 3 centimeters. It is cut into smaller cubes of equal size of length 1 centimeter. Then find the number of cubes without color on any face. Now what I will do, I'll give you the formulas, right? So first of all, first case here is you have 5 particular cases that you can observe. So among them, the first one would be the total number of cubes. So total number of cubes. So the question actually over here is, there is a cube of 3 centimeters and it has been cut into smaller cubes of 1 centimeter each. So the cube basically would look like this. Right. So now you need to find the total number of cubes. Total number of cubes, what I will do, I will take capital X as 3 and small x as 1. So my total number of cubes would be 3 by 1 whole cube. That is capital X by small x whole cube. This is the formula, right? So 3 cube is 27. So my total number of cubes are 27. That is the first part. Then I want to find number of cubes that are painted on 3 faces. Number of cubes painted on 3 faces each. Now, if you observe in the topmost corner over here, this particular cube will have 3 of its faces painted. Similarly, this one, this is not a 3D shape, right? So similarly that one. So all the 8 corners will have cubes which have 8, which have 3 faces painted. So number of cubes having 3 faces painted. So it is always 8. Number of cubes having 3 faces painted is always 8. Now I want to find the number of cubes that are painted on 2 faces. Number of cubes painted on 2 faces. So now these 2 faces are nothing but cubes which look like this. So which are in the middle over here. This cube has only 2 faces painted, right? So now what happens? Along one edge, I have one such cube. So there are 12 edges. So 12 into 1, it would mean 12 cubes. So number of cubes that have 2 faces painted would be 12. Also, I can give you the formula. So the formula for this is 12 times x, capital X minus 2. So 12 times of capital X is here, over here is 3, as I have stated previously. So 3 minus 2 would be 1. So 12 ones are is 12. So this is the formula if you want in case, right? So for total number of cubes, the formula was capital X by small x whole cube. For 3 faces, it is always 8. Whenever you have a complete cubes cut into pieces. For 2 faces, it is 12 times of x minus 2, right? Now, moving on. Now, I want to know the cubes that are painted on only one face. Now, if you observe here, in this particular, I have for each face, I have one particular cube like this. So the number of cubes that are painted on one face would be 6 faces into one such cubes. So 6. So the number of cubes that are painted on one face would be 6. Right. So if you need the formula is 6 into x minus 2 whole square. 6 into x minus 2 whole square. That means 6 into 3 minus 2 whole square. So 6 into 1 square is 6. Right. Then the question actually here is the number of cubes without color. So that is my question. Now I want to find the number of cubes without color. So that would mean total minus number of cubes painted on 3 faces plus 2 faces plus 1 face. Right? 27 minus 8. Okay. Plus 12 plus 6. So 27 minus 26, my answer is 1. Right? This is a difficult question, but knowing the formulas would help you. What are the formulas? I'll list out. Observe. 1 second. Right. Observe. Painted cube model. So the bigger measurement, you will take it as capital X, or original measurement also you can say. The smaller pieces that are cut, you will take it as small x. So number of cubes, total number of cubes, it is given by capital X by small x whole cube. The number of cubes that are painted on 3 faces, it would always be 8. Right? If you want me to draw the diagram for a 5 by 5 cube, So my total number of cubes, it is given by capital X by small x. So here in this case, my capital X is 5 and small x is 1. So my number of cubes would be 5 by 1 whole cube. That is nothing but 125. And the number of cubes that are painted on three faces is 8. And the number of cubes that are painted on two faces, if you observe over here, along this edge, so number of edges 12 into this type of cubes, right? So here two faces are painted, right? So 12, you have 3 over here, so that is 36 cubes. Now if you want the formula for two faces, the formula is 12 times capital X minus 2. So if you substitute 5, it would become 12 times 5 minus 2. So 12 threes are 36. That is what you have over here. Then moving on to cubes that are painted on one face. Right, if you observe over here, see these cubes 1, 2, 3, 4, 5, 6, 7, 8, and 9. These cubes, they are painted only on one face, right? So for one face you are having 9. So you have 6 faces altogether. So 6 times 9, you would get 54 cubes, right? So what happens? What is the formula for this? 6 into x minus 2 whole square for one face, right? That is the formula. So for this one, it is 12 into x minus 2. Now you want to find the value, I mean the number of cubes that are not painted. So number of cubes not painted on any face, not painted on any face. That would mean total, that is 125 minus 8 plus 36 plus 54. So 125 minus 98, that is nothing but 27, right? So these formulas are important to solve the answer quickly, right? Hope you understood. Thank you. It's a very easy kill topic and hope this helps.